Hi, this is Dr. Eddie Morgan over at Clovis East High School, ready to help you with your homework tonight. Tonight we're looking at Math 1, Worksheet 5.4. Remember that every problem on your homework is mirrored by an exact problem on this homework help. So if you have a problem with a particular problem, just fast forward to that slide and we can help you out. Let's get the first three problems ask us for each exponential equation to state whether it's increasing or decreasing, and then what's the growth factor, or if it's decreasing, the decay factor, and what's the initial amount. Well, this basically comes down to recognizing the elements of an exponential equation. And I'll write it down here, just a reminder. Typical one looks like this, b to the a times b to the x. This number here, a, is the initial amount, okay? This number b is the growth rate, the growth factor, or decay factor if it's going down. Now, the way you know is if b is greater than 1, then it's increasing. But if b is less than 1, then it's decreasing. Okay? So that's all the information you need to solve this. So I look up here, first of all, and I look here in 5. 5 is greater than 1, so this one is definitely increasing. At the same time, what's my growth factor? It's 5. And what's my initial amount? 25. Pretty simple. Next one, here's my factor here. 4 is greater than 1, so that means this one too is increasing. If you think about it, you take something and multiply it by 4, it gets bigger. Take something and multiply by 5, it gets bigger. And my growth factor is 4. That's the factor is something you multiply by. I'm going to multiply this by 4. And my initial amount here, 18. So you can see I'm going to take 18, then I'm going to multiply by 4 once, and then by 4 again, and by 4 again. On the third one, however, notice here my factor here is 0.3, and that's less than 1. 3/10 is less than 1, so this one is decreasing. And the growth factor is, in this case, it is a decay factor. These were growth factors. This is a decay factor, 3/10, but my initial amount here is 21. As we look at 4, 5, 6, and 7, again, we're asking, is it growth or decay? And I remind you that in your typical exponential function, this is your factor, and if that factor b is greater than 1, then it is increasing. Or we say that is growth. It's growing up. On the other hand, if it's less than 1, then this is decreasing, or we use the terminology decay. So as I look at these, I just have to look at this b factor. And in all of these, you notice a is just 1. This is 1 times that, 1 times that. So notice 1/2, that's less than 1. So this is decay. 4 is greater than 1. So that's growth. 5/2, remember that's 2.5. That's greater than 1. So that's growth. And 1/4 is less than 1. Just ignore that. Don't worry that that's different. And we have decay again. Okay? Problem 8 says that if population of fish decreases 8% annually, what is the decay factor? All right, you start with 100%, but then it goes down by 8%. So that means after 1 year, you're going to have 92% of the fish. So in other words, if I started with 1,000 fish and I wanted to find out how much it was, I mean, I could multiply it by 8% and then subtract it, or I could just multiply that by 92%. Now remember, you never write it as 92%. Remember that percent sign means divide it by 100. Or in our case, we make it a decimal, and we would make it 1,000 times 0.92. And if this happened year after year, we'd say each year goes down by 9%. So our decay factor is 0.92. Okay? Think of it as 100% minus 8% is 92%, or 92 hundredths. That's my decay factor. In problem 9, the number of students enrolled in high school is 3,000, and it's growing 7% each year. What's the growth factor? In this case, we start with 3,000, but we're going to add 7% of 3,000. Okay? And that's how we would find the next one. In other words, what's my growth factor is I start with 100%, and then I'm going to add 7%. So I could take 3,000 and multiply it by 107%. And again, remember, percent just means divide by 100. So that's the same as 3,000 times 1.07. If I were writing this as an equation, then the equation would be 3,000 times 1.07 to the x power. And notice what my growth factor is. My growth factor is 1.07. The way to think about the growth factor again is it increases 7%, so you get your 100% back and you add 107% to it like we saw here. And that gives you your growth factor, put in a decimal, 1.07. Number 10 says, suppose your friend's parents invest $15,000. Oh, that's my initial amount. In an account paying 6% interest compounded annually. All right, so it's going to grow 6%, and they want to know what it'll be after 10 years. So if we're thinking about our equation here, the initial amount is 15,000. The growth rate is not 6%. Remember, that's 100% plus 6%. So it's going to be 106%, or in a decimal form, it's going to be 1.06. And then in this case, our x is going to be 10 years. So what we have here is y equals 15,000 times 1.06 to the 10th power. Okay? At this point, this is when you're going to want to have your scientific calculator. Okay? And as I mentioned earlier in one other one, I'll just make a little note down here, depending on what scientific calculator you have. I've seen two or three different ways this happens. In the ones that we use in class, there's a little button called a caret key. So if I were doing this problem, I would type in 1.06, and then I would type in the caret key, and then I would type in 10, and then the enter button, and it would give me my answer. Other calculators have a key that looks like this, and then you do 1.06, and then that key, 10, whichever one you have. Now I start by doing my exponent first, according to PEMDAS, so I'm going to put in 1.06, and then that key to the 10th, and that gives me a nice long number, 1.790847,697. Now, one thing important here, leave it right on your calculator screen. Don't write it down, just leave it as it is, and then just multiply it by the 15,000. And I end up with y equals 26862.71545. But we're talking money, so we can round off to the nearest cent. Notice there's a 1, but there's a 5 next to it, so that's enough to round up. So my answer would be $26,862.76. So if your friend's parents put $15,000 in an account that gets 6% per year, after 10 years, that $15,000 will have grown to $26,862.76. Number 11, a business purchases a computer system for $6,000. So that's our initial amount. If the value decreases, in other words, it depreciates 10% per year, so it's going down, how much is the computer worth after 5 years? So once again, let me just write our equation down here and we'll figure out our A is our initial amount, and for here, the computer starts out being worth $6,000. Our rate, in this case, it's a decay rate. It starts at 100%, but it goes down 10% every year. So 100% minus 10% is 90%, or what I'm looking for here is 0.90 is my decay rate. And then X is the number of years, and that's going to be 5. So we can write our equation here. Y equals 6,000 times 0.90 to the 5th year. Okay? Again, do the exponent first. So if you type into your thing 0.9 and then either use the caret key if you have, like, if that's what yours is, or the X to the Y key. You're either using a key, usually it looks like that key or that key. So I'm going to type in 0.9 and then that key, and then I'm going to do it to the 5. And I end up with 0.59049. Okay? Again, if you're not sure about this, you would do this. You would do, if you have the caret, you'd do 0.90. You'd type in the caret key. You'd put in 5 and put enter. Or if you have one that looks like this, you do 0.90, press that key, 5, and equals 0. You just have to find which key it is that does the exponents. Now again, once you do that, don't write that down necessarily. You can write it down, but don't leave it. Just leave it on your screen in your calculator, and then just hit the multiply button and multiply it by 6,000. And my answer here is 3542.94. So I don't need to round that off. And that gives me that after 5 years, that $6,000 computer is worth about $3,500. Now, problem 12 is easier than it appears. It has to do with compounded interest, and the formula that they've given you here is for compounding if you want to compound something other than annual. Like if you have a bank that compounds monthly, in here is the number of times you do it in a year. So like if you did monthly, you would put N as 12, but in our case, we're doing this annually, so N is simply 1. All right. So in this case, our principal here is 12,000, and our rate is 3.5%. But remember, whenever you use it in a mathematical, you need to change it to 0.35. Move this over twice, and that's our rate. So we can put this in here. The amount is going to be the principal, 12,000, times 1 plus, and my rate is 0.035 divided by 1. And then this is going to be 1 times 4 years. This is my T. If I were computing this, if I were compounding it, say monthly, this, instead of being 1, this would be 12. And that's how that would work. So in other words, simplify things. This is 12,000 times 1.035 to the 4. Okay? So let's do our calculator again. Remember, our calculator would be, start here with the exponent would be 1.035, and then the caret or X to the Y button, whichever, 4 equals. So let me do that on my calculator. 1.035, and that's to the 4. And this is going to end up giving me 12,000 times 1.147523001. Do not erase that. Just simply hit multiply times 12,000 to get your answer, which is 13,770.27601. I'm going to round off to the nearest cent. I go next door, and he's 6 years old. It's old enough to go to school, so I'll round up. And my answer will be, I will then owe 13,770 and 28 cents after 4 years. So that's how much I owe borrowing money at 3.5% after 4 years. Number 13, if you purchase a car and you borrow $9,000, so this is your principal, at 6.2 interest rate, that's your interest rate is R, how much will you owe after 3 years? 3 years is the number of years. If the interest is compounded yearly. Yearly means that N equals 1. Again, if you were compounded monthly, it would be 12. Some banks compound daily, and N equals 365. But we're just looking at yearly at the present time. So let's write our formula with what we know. The principal is $9,000. Our growth rate is 1 plus, my rate is 6.2%, but remember 6.2%, move the decimal over 2, is 0.062, 6.2 hundredths. Okay, so we're going to have 0.062 divided by 1, and that's going to be 1 times 3. So to simplify things here, I have 9,000 times 1.062 to the third. Okay? And so, now let's get out our scientific calculator. If you have a calculator, you're going to do this. You're going to get 1.062. You're either going to use the caret button, or maybe your calculator has this kind of button, and then put in 3, and then enter. So let me do that right now. 1.062, my caret button to the 3, and that's going to be 9,000 times 1.197770328. And again, leave it there and just hit the multiply button and multiply it by 9,000. And you get A equals 10,779.93295. We want to round off to the nearest penny. Notice there it's a 2, that's less than 5, so we round down. And our answer is, after 3 years, we're going to owe $10,779.93. So that's how much we'll owe if we haven't paid anything in 3 years. Compounded annually or yearly means that every year they add the interest, and then the next year you pay interest on your principal and on the interest that you owe from the year before. That's why it gets compounded. How can you tell if an exponential function models growth or decay? That's very easy. Remember, our function looks like, our exponential function has this form. Look at this factor. If b is greater than 1, you have something that's growing. In other words, if b were 2, you're doubling it each time. If it's 3, you're tripling. If it's bigger than 1, you're multiplying by a number that's bigger than 1, so it's growing. On the other hand, if b is less than 1, like a half, when you multiply by a half, you're cutting things in half, so you have decay. In other words, if I have y equals 10 times 5 to the x, 5 is greater than 1, so I got something that's growing. It's always being increased, multiplied by 5. On the other hand, if I have 10 times 1/2 to the x, now 1/2 is less than 1, so I'm cutting it in half every day, so this is decay. All right, to look at the error, I usually just try to work the problem without looking at it, and then each step see if they did the same thing I did. So notice here, student deposits $500, so that's my principal, okay? Or, all right, so I'm going to have A equals 500, so we're good there. And then it earns 3.5%, so I'm going to have 1 plus 3.5%. And remember, percent means divide by 100, so that's 0.035. So this is 0.035, And then my years are, I'm going to do this quarterly. So quarterly means n equals 4. So this is divided by 4. And then it's going to be over 2 years t, so it's 4 times 2. All right. Now, if you notice here, we've already found the error. The error is right here. Notice that what they didn't do is they did not change 3.5% to its decimal form, 0.035. And that's going to be their error. Okay. This would be like 3.5 here would be like increasing it 350%. So if we finish the problem here, if I take 0.035 divided by 4, that's going to be A equals 500 times 1 plus, and this is going to be 0.00875 to the 8th power. Okay, so that's going to be 500 times 1.00875 to the 8th. So get out my scientific calculator, and I have 1.00875 to the 8th, and that equals 1.072181679. And now I'll multiply that by 500, and I get 536.0908394. Let's round off here. That's a 0. Easy round off. That's going to be $536.09 is the correct answer. Okay? So that's going to be our amount there. Notice how much that shows just comes up to 536, whereas this guy up here, he ended up with $76,000 after 2 years. Obviously something was wrong. All right. You have a good evening.